Okay, so this video will be topic will be more on measures of dispersion. Okay, so you can see that in the McGraw-Hill book, Business Statistics 3.4. Okay, so measures of dispersion. Okay, we go directly. Okay, we go directly to the task at hand. Okay, so for example, okay, the first one is the range. Okay, how do we compute for the range? Okay. Um, Actually, we already have used. Right. Okay, so the range here. Okay, so we're gonna use a max. Okay, max. Okay, so what's the? Okay, so that's the max, and then uh, this is the max, and then you less that by. You can just less by mean. Okay, let's copy this one. Okay, and then we'll make this one a C. C. Okay, enter. So the range is 126. Okay, I'm sorry. All right, I'm sorry. Okay, so the range for growth and value. I'm sorry. I need to put some range. Okay, so I'm still gonna use B. Sorry for that. Okay, and then that's 120. Okay, to 38. This one it's 90.6. Okay, I just copied the formula, huh? Okay, so that's the range for growth and value. Okay, now that we're finished with range, let's try to check that in um, let's proceed. I'm trying to get this to R, but let's try to proceed first with Excel or in Excel, and then later we'll proceed with R. Okay, so the next one is the MAD. Okay, MAD is stands for mean absolute deviation. Okay, mean absolute deviation. Okay, uh, is an average of the absolute differences between the observations. Okay, so we'll get right through it. Okay, so the math for mean absolute deviation. To get the mean absolute deviation, okay, so first, just have to copy this one again. And then P2 and P37. Okay, and this one P2 and P37. Okay, so I'm gonna change this one. I'm sorry. Just have to try to direct this one to here. So we have to use this one. Sorry. Sorry. Okay. So let's try directly to get to that. It's average deviation. Okay. And then just highlight this one. Okay. You got 17.49. Okay. This one is 13.67. Okay. So that's the mean absolute deviation. Okay. So it just means that the growth span is greater than values of than value. Okay, uh, since this we are measuring this first, it just means that the growth section is more dispersed than the value. Okay, so the next one will be, okay, the next one will be the variance and the standard deviation. Okay, so to get the variance, okay, variance first. What's variance? Okay, it's a standard deviation. Actually, variance is just it's just the what do you call this? It's just the what do you call this? Um, it is the if you will uh, for example the standard deviation, okay, and you raise that to the second power, okay, you got the variance, okay, or the standard deviation is just the square root of variance, okay, so that's how it works. Okay, so let's check for the variance for, so we have here 2. Let's select the S because this is sample. Okay, so there. So the variance is 566. Okay, that's the variance. How about the value? The variance is 323. Okay, so now if we make it, if we try to get the standard deviation, what we're gonna do is STD S. S because this is a population. I mean sample. Okay. So to check if this 23 and 17 is correct, I have to get the square root of this one. Okay. So right, I have the same answer. So square root of, okay. So that's the relationship of variance and standard deviation. Okay. So the next one will be the coefficient variation. Okay, CV, coefficient variation. Just have to write it. Okay, so coefficient variation is just basically standard deviation over population. Okay, I mean mean population or mean sample population. Okay, so to get that, you just have to divide uh, this one by the mean. Okay, let's get the mean first. Mean. Okay. I'm gonna copy this one already. I'm tired of. Okay. This one. Okay. Sorry. What happened? Is something wrong? Okay. So to get the coefficient of this, we need to let this one. Okay. Okay. So the mean for this is just have to copy this one. Okay, we have to change this one into average. Okay, and this one average. Okay, so it's 12. So in order to get the coefficient variation, you just have to divide this one by mean. Okay, and this one also you have to divide this one by the mean. Okay, so the difference is really slight. It's just 2.02, around that one. That's the difference. Okay, around 0.012. Okay, that's the difference. So there are no it's slightly different. Okay, so now that we're finished with the showing to you how to see the measure of dispersion. Okay, we're gonna go ahead and try R. Okay, so let's open R. Okay, and then import dataset from Excel, and then go to desktop, go to R chapter 3, and we'll rename this as my data. Okay, and then we'll look for growth value, and then import. Okay, so that's how to do it. Okay, so now that we have the data, we can now get the range. Okay, so for range for growth, you just have to type range, and then my data growth, and then enter. Sorry. Okay, so this is the range. Okay, my data at growth. Okay, it's for this range. Okay, so we have 100. Uh-huh. Okay, so that's how to, and this one also the range for my data. Okay, my data uh, value. Okay, so it's 46 using 44 plus 49. Okay, so max, okay, 48, I mean 79.48 minus uh, minus. Okay, so that's 120.38. Okay, so it's just a the range here doesn't really shows us, just give us the minimum and the maximum. Yeah, minimum and maximum, like this one. Range from my data value, it's 44 minus 48. So we just have to compute manually. Minus 46.52. Okay, so that's 90.6. We've seen in the computation from Excel. Okay. So the next one will be the mean absolute deviation. Okay. So to get that, okay, using R, okay, so the mean absolute deviation to get the mean absolute deviation, you gonna ask not to get lost. So the mean absolute deviation, um, so mean and then abs, okay, and then my data and then growth, okay, and then you less that by uh, okay, so less by the mean also of my data. So, my data dollar growth. Okay. Okay, let's try to check that. Okay, so we have 17.49. Let's try to check that in Excel. Okay, so we have the same answer, but it's easier doing that in Excel. Okay, I do admit. Okay, and then okay, let's try to do that value. It's the value. Okay, absolute value. Okay, you just have to type that and then also value here. Okay, and then enter. Okay, so 13.666. Okay, the same. Okay, so the next one will be um, measure of dispersion. Okay, so the variance and okay, variance and standard deviation. Okay, so to do variance, just have to type my data and type road. Okay, so that's it. Okay, so the variance is 566. Let's check that. Okay, it's the same. How about standard deviation? Change this one to SD, and this is what we got. 23.17. Okay, we got that also. 23.17. Okay, and also variance again. My data dollar value. Okay, and then enter. So we have 323. Okay, also got 323 here. So and then let's try standard deviation. 17.97. Very same. Okay, and to get that, to get the coefficient of variation, just have to manually uh, type this on 353. It's just a calculate. It feels like a calculator. Okay, 2512 over 17.97 919. Okay, so 17.97. Okay, so I think I messed out some important data. Okay, so sorry. Must be the standard mean. We just have to get the mean first. Okay, so since I already have done that, so we have to get a new sample for value. Okay, so 12.05. Okay, this one here. Okay, so we'll divide this one by the standard deviation. Okay, huh? So this one 17 over 7 919 over 12.005. Okay, so 104 1.49. Okay, okay, 1.49, the same as here. Okay, so I guess that's all. I'll see you around.